Hello everyone, this is the video lecture for Pre-Calculus, Chapter 11.2, Ellipses. So an ellipse is kind of like a circle, but it's not a circle anymore. It's bigger on one side, something like that. Let me go ahead and give you the formulas. So we got x minus h squared all over a squared plus, and then y minus k squared all over b squared is equal to 1. And that's it. All right, let's go. Well, hold on. I'm different. I'm a very different person than most other folks. Maybe you learned this formula. Keep doing that formula. Awesome. If you don't know what's going on, let me teach you something new. So, I always consider the major is always bigger. What do I mean by major? Major is always bigger. The major is, in my opinion, I'll give you a little bit more later, is that distance that's the bigger distance from the center. Okay? Here, this is a major. And if you have a major, then the other guy is called a minor. So the minor is going to be these guys. Notice that the minor or major is independent of x and y. It kind of just changes depending on the problem. And so let me give you my own formulas that are not conventional, but I'm going to be using them. So I say it's x squared over major squared and y squared over the minor squared, or, and then I got the x over the minor squared, and then the y over the major squared. Okay. The reason why I chose to kind of split it up is because A and B are so ambiguous, but major minor are actually important to me. They determine what my shape is going to be. If I have an X major, then it's going to be this kind of guy. If I have a Y major, it'll be this kind of guy. Try that a little bit better. There we go. Okay. Anyways, so if you can find the bigger number, then you can just see if it's going to be this way or that way. 50-50 shot on the graph already. One last note, just because my way's a little different than the books and all that kind of stuff. This is not to be confused. Not to be confused. Confused? Yeah, with major axis and minor axis. Okay. Now I'm going to use major minor all of the time. Been doing it for years. But when they say major axis, they're actually saying 2 times your major. I always put a capital on major because it's major. And then 2 times minor. Minor gets a little m because he's minor. There you go. You're going to see this occasionally. It's not a very big part of this section, but they will ask for it occasionally, and we have to know what they mean by major axis, minor axis. It's kind of like that focal distance was that 4p from the last section, is the whole entire 4p, not p itself. That's the same idea here. Okay. So 11,2007. They start with 4x squared plus y squared is equal to 4. And they want to say, what graph is that? Give me the better equation and all that kind of stuff. Well, first off, all my equations have an equals 1. Equals 1, equals 1, equals 1. And so I need to divide by 4 immediately to get an equals 1. So the 4s are going to cancel here, leaving just a 1 in the bottom. But the 4 is going to be retained here on the bottom of the y. Now, every formula also has a square. So that's technically 1 squared. But 4 is a 2 squared. So I guess you could say I'm taking the square root of that. Square root of 1 is 1, square root of 4 is 2, and then I'm like having it squared there. I'm doing this so that I could see the actual major and minor. Major is always the bigger one, and my minor is always the smaller one. With these in hand, I can graph this immediately. Y, I'm going up a distance of 2, but my minor x is only going out a distance of 1. Try to draw that a little bit better. There we go. Cool. There we go. That was my graph. Again, 2 distance for the y, 1 distance for the x, major, minor. That's why I like that style over the AB stuff, because it's just so ambiguous. This here is straight up every time. I got 16x squared. Oops. Trying to make that x look a little bit better. Plus the 25y squared is equal to 400. Again, every formula has a 1 at the end, so I'm going to say equals 1. Now, I'm going to divide these out. 16 over 400 is actually a 25, and 25 divided by 400 is a 16. It's not always like this, but I found that it's often swapped, I guess you could say. I want to make a point, though, that every one of these is still centered at 0, 0. Like the last time with the parabolas, what I honestly should be doing is something more like this. That way you can see that it's centered at 0, 0. And occasionally I will do that, especially here on the next coming up problem here in a second, okay? Anyways, this is not good enough. I want to find out what the majors and minors are. So this is a 5 squared. This is a 4 squared. Again, looking at these numbers here, I could see my major is an x, my minor is a y, so I got a major x, minor y, so it's going to be a sideways ellipse, and I'm going out 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, up, 2, 3, 4, 2, 3, 4, 5, so something kind of like this here. It's a little bit more on the x than the y. There you go. Cool. Next question. 11,2,0,0,9. So I got x squared all over 25 plus y squared all over 16 is equal to 1. I'm going to rewrite this as x minus 0 squared all over 5 squared and y minus 0 squared all over 4 squared equals 1. You know what's funny? I just saw that formula a minute ago. Woohoo! Everyone's going to get different numbers on your randomization, so I'm just showing you this is what happened to me. So again, I have a major for sure of 5, and my minor is a 4. So the graph looks identical to what we just did a second ago. They're not really looking for that in this case, though. They're wanting to know where's the center. Now notice that center and vertex here are different. There's actually vertices, and I'll show you those here in a second, but let me graph it so that we're all good. There we go. That's about what it would be. Again, 4 distance this way, a 5 distance this way. So my center is at 0, 0. Okay? Let me do this right here, split it up a little bit. Okay. So what I do in WebAssign is that I have my center 0, 0, and again, that's going to be not this particular problem, but later on, they'll actually want to know that as well. And then for every other problem going on, I'll rewrite my center for both vertices and foci. Now, I'm pretty sure that what WebAssign wants in this case are 2 different vertices. You'll have to do something kind of like this, and then another one kind of like this here. Okay, like so there's just so many. I'm just going to put a plus and minus always because it makes it a little bit quicker. But that's how the format is. We're always going to have that same center all the way down. What if it were a 2, 3? Well, you need to write 2 3s all the way down, and then you change the values appropriately. Okay, it's a format. So we want to know what the vertices are. Vertices are for the majors. Vertices are always tied in with the majors. Okay. So the major is an x, so my x values are changing by 5 distance each. Basically, it's at 5 distance plus or minus 5. So you're going to go over here on the x value plus or minus 5. That's your answer. That's your vertices. Done. Notice again, I set it up. I'm ready to put whatever I need in there. I put my center. Everything's good to go. And now my vertices are going to be plus and minus the 5. It's always associated with the majors. There's not something associated with minors. There's not like co-vertices or something. I don't know. But we're not going to talk about those because they don't really care about those. The foci are interesting because this is a little different than what we had for the parabolas. Foci are always on the inside of the ellipses. And they're not the full distance. That's not a minor distance. What it is, that distance here, is called c. It's a c distance. So in a way, we're going to have plus or minus c here again on the x distance. I don't know what c is, though, and I have not given you a formula yet. So let me go ahead and show you the formula for c. To find your foci, your c formula is c squared is equal to major squared minus the minor squared. Always. Notice the bigger minus the smaller. Well, I have my major is 5 squared. My minor is 4 squared. 25 minus 16. And so you get a positive 9. So that's c squared. C squared is equal to 9. How do you get c? Well, you square both sides. And c equals 3. Again, that distance is 3, but you're going to want a plus or minus 3 to actually get both foci answers. So like if this is over here at 5, negative 5 and 5, then this guy right here is at 3 and negative 3 on your number line. Okay? Cool, cool. And then they ask for the eccentricity. Eccentricity. So what they're asking for is little e, not 2.7828, but something else. Little e is equal to, here's your formula, c over the major. Notice that I keep using major minor in my formulas because it makes sense. Everything here is focused around the major minor formulas. Okay, so I have a c, which was a 3. I have a major, which was a 5. And there you go. You're done. That's it. This problem keeps going. It says length of the major axis. Again, that's just going to be 2 times your major. So then 2 times your 5 is a 10. And then length of the minor axis, 2 times your minor, 2 times the 4 is a 8. Okay. There we go. Phew, that was a lot. And that was only one question. We got a lot more to go. Oh, not 4. 11, 2, 0, 2, 0. So I got 2x squared plus 49y squared is equal to 98. If I were to divide that 98 immediately, what you're going to see is that we get them flipped. This is essentially the 49 and the 2. What's interesting here is that when I square root them, I got a 7 squared. And what do you get here? Well, you get the square root of 2 squared. Sometimes you're going to get something funny like that, but that's okay. That's your major, much bigger than this guy. And this is your minor. And so now I can already start drawing my graph if you want. X major, this kind of style right here. That looks good enough. And then out to 7 and negative 7. Okay, so there's my graph. Already pretty good. They're going to want a lot of different things. So let's go and find all my little nitpicky things like c. So c squared. So again, the major squared minus the minor squared. So we have 7 squared minus the square root of 2 all squared. 49 minus 4 is 45. Again, that's c squared, so c is equal to the square root of 45. We'll be using that here in a minute. And then lastly, e is equal to c over major. I have a c. My major was a 7. Well, there you go. 47. Why did I have a 47 on my formula here? Oh, you know what? I messed up right here, guys. Hold on. Sorry. Square root of square cancels, makes a 2, not a 4. That is definitely my blunder. Sorry about that. I'm not going to erase that on the video. You could see I'm a human too. But that's why I have notes to go and double check myself once in a while. Like, am I even doing this right? Okay. And you were using a pencil, correct? Okay, sorry about that. I definitely messed up again. What would I do? I thought 2 squared is 4. No, it's the square root of 2 squared. The square root and square cancel make a 2, so that's obviously a 47. So that it changes things. Anyways, there's my answer for my E. And so now let's go ahead and start putting it all out. Here's my answer. So start with the center, which, of course, in this case is 0, 0. Remember that my vertices are driven by the majors, okay? And again, my majors are on X, right? I have an X major. Yep. And it's a 7, so I say plus or minus 7 for my X values. My foci are going to be the same thing on my X's. 0 plus or minus my C. My C value was the square root of 47. And you can see I'm getting this very quickly. You don't have to do a lot of crazy math or calculations. If you went and got it wrong a couple times and see what they simplify it down to, not so much in this section, but in other ones, it really just looks crazy. So I would suggest keeping that same format all the way down. Look, 0, 0, 0, 0, 0, 0, comma, comma, comma. I do that on purpose because later on in the other sections, you're going to have numbers there. And again, weapon sign, you don't have to simplify. You just leave it alone. This is great. Everyone's happy. They're going to ask for the E and the C, and well, we already have those. So those are okay. The major axis. Major's always got to have a capital, of course. If you remember, it was 2 times that 7 makes a 14. And then my minor axis. 2 times the square root of 2. Which is 2 square root of 2. Okay. Cool, cool. 11, 2, 0, 28. I got y squared is equal to 1 minus 3x squared. Well, first off, I need 1 equals blah, blah, blah equals 1, whatever it is. So move this guy over. I got a positive 3x squared plus 1y squared is equal to 1. And here's where it's interesting because I actually need it with a division, right? I need divided by major, divided by minor, and all that stuff. Well, I don't really have that right now. Where's my division, right? Divide by 1, maybe? Well, and this 3 doesn't belong in the numerator at all. I need to bring him down into the denominator. How I do that is I say we're divided by, this is really weird, okay? We're divided by a 1/3, okay? And here I'm just going to make it a 1 because it doesn't matter. Divide anything by 1 is just 1. Or it's itself. So I took this 3 and I flipped it into the denominator. So if you're divided by a 1/3, it actually makes a 3. I know that's very strange, but we're doing it on purpose so that I can have my major minor, have a certain look. Well, again, this is not good enough. We still need to do more math. It's the square root of 1/3 all squared. Square root and square root cancel. And again, this is just going to be a 1 squared. Now, we have a major and a minor, and I'm wanting to know which one's bigger. And you could probably guess that the 1 is actually bigger than the square root of 1/3. You can go back to your calculator and find that out if you want to, decimal-wise. But major is actually a 1 in this case. For all of what we have, it's going to be an up-down kind of ellipse, something like that, okay? Again, this is a 1 distance going up and down. I think we have everything we need for the other formulas. So c squared is equal to major squared minus the minor squared. And so my major was a 1 squared minus the minor is the square root of 1/3 all squared. And I know that it's simply just those 2 denominators subtracted. I know that you're thinking that, and that's good. I'm just wanting to make sure that you're okay with this all the time. Square root of these things. And so I get, well, the square root of 2/3. Yay! Whatever that is. And then my E is going to be C over the major. My major is a 1. So the square root of 2/3 all over 1 equals the square root of 2/3. So that's actually one of the answers you need. But now let me go ahead and start writing this out. My center is again at 0, 0. I'm going to leave a little gap here for the y. My vertices are always driven. They're always conforming to the majors. Majors are on my y's. It's a y major. And so leave your x's alone, plus or minus. For the y value, my major was a 1. Foci are the same thing. It's going to be for my y values, plus or minus c. My c turned out to be the square root of 2/3. I mean, and that's already most of your answers. That same format, 0, 0, 0, 0, 0, 0. This is a good method. This is a way to get things done quickly. Okay? We already got our E. Very good. And then last thing again, just to make sure, major axis. 2 times the 1 is a 2. Minor axis. 2 times the square root of 1/3 equals 2 times the square root of 1/3. Or I guess you could say 2 over the square root of 3. That's another way to do it. Okay. That's got to be a capital M. Major. Okay. Phew. Those are big questions. So on to smaller questions now. Basically, we're given a graph, find the equation. And so they give me this ellipse like this. I can't draw ellipses very well, but you're going to have to just get over that. This is a 6 distance this way. And this is a 5 distance that way up. So maybe I don't draw it well enough. Let me try one more time, but in a different format, I guess you can say. This over here is x equals 6. Okay, this guy right here is a y equals a 5. So I'm saying that this is going to definitely be my major because he's bigger, and this is going to be my minor because he's smaller. Okay. Look how we can just already start putting this all together. Centered at 0, 0. X is a major. You can also just say it's like your x distance, but that's good enough for now. There you go. Of course, you can remove all the zeros and make it look pretty, or not. 11, 2, 0, 3, 3. Another one. So I have an ellipse that does something like this. It's going out to x equals 16, and there's another point right here at 8, 6. 8, 6 is another point there. So I want to go ahead and start figuring it out. You can obviously see that we have a major here at 16, but I have this other xy point which I don't quite yet know. Let me just go ahead and fill out what I do know. So x squared over, and that's an x major, by the way. It's an x major. So 16 squared. Y squared over minor squared. I don't know what the minor is. Equals 1. I mean, this is it. This is my formula. The problem is that I don't know what my minor is, but I have this other point. I have this xy. So I'm actually going to plug in the x and the y just as you see it. I'm going to use little m for minor. It's much easier to do math this way. So I'm going to move this over to the other side. I don't even know what these numbers are yet. To get little m by itself, I'm going to actually multiply it to the other side and divide all this to the bottom there. So they're basically just flip-flopping in themselves. M squared is equal to 6 squared over all this stuff. And then you square root both sides. That is a big handful to put into the calculator. So you could do it all at once or as you keep going. What actually ends up, it's kind of funny, if you do the inside numbers, don't do the whole square root, just do this inside numbers right here. And what you end up with is the square root of 48. So all this right here on the inside actually ended up being just 48. So that's kind of nice. And so that's my minor. So now I can go back and say x squared over my major squared, so 16 squared. Then y squared over my minor squared, so square root of 48, all squared, equals 1. There we go. Okay. Keep cruising. 11, 2, 0, 4, 4. I got foci at plus or minus the square root of 10, 0. And I have vertices at plus or minus 7, 0. Notice that this is a 0 right here. Do you see that? That's that format. So, I mean, I can already tell you that my center is at 0, 0. Again, I know that we already have this. It's all part of the sections of 0, 0, but later on it's going to be important. So, cool, we have a lot of information here. Remember, the vertices are primarily from the majors. So I have a major of 7 already. And it's an X major. Notice that because it's on the X values, it's an X major, not a Y. And you could tell from over here on the foci stuff too. You can definitely see that my C is equal to a square root of 10, so that's good. So let's do that formula. So I'm going to use a capital and a lowercase just because it's quicker. So I got square root of 10. My major is a 7, and I'm going to try to find my minor. So I got a 10 is equal to 49 minus m squared. To get m squared by itself, I'm going to add it and subtract. M squared is equal to 49 minus the 10, which is 39. And so you can guess that my minor is the square root of 39. Cool. With that in hand, I think we have everything. Major, minor. I don't think we even need anything else. So x squared over, again, x is a major, so he's going to get that major value of 7 squared. My y was the minor, so the square root of 39 squared. And there you go. Again, I'm not simplifying because I don't need to. 11,2054. So this time they say that my eccentricity, I don't really spell it well. Eccentricity, your little e is equal to 0.25. Okay. And they say that my foci are at plus or minus 0.5, comma 0. Notice again, my foci are on the same axis as my majors. These are telling me that I have an X major. Now, I don't know what that major is right now, but I do know that it's along the x-axis. Okay? Well, what I do know from this is that C is equal to 0.5. I mean, we can get that much. And E is equal to this much. So is there something that ties them together? E is equal to C over major. And so then I'm going to get rid of those equal signs here. I got 0.25 is equal to 0.5 divided by major. I'm just use capital M if that's okay. Solve for capital M, so I'm going to move these over. Capital M, major is 0.5 over 0.25. And I divide those out, and I get a 2. So that's my major. And notice again, that's an X major. Okay, so that's a handy thing to know. To find my minor, I go back to the C squared is equal to major squared minus the minor squared. 0.5 squared is equal to 2 squared minus the minor squared. Move it over. It's supposed to be an arrow. Minor squared is equal to 2 squared minus the 0.5 squared now. So that's 4 minus 0.25. 3.75. It's supposed to be a 4 there, I guess. Close enough. You can do the fraction stuff and whatnot. I did a fraction in the calculator. 15 over 4. Good enough. And so there's my minor. And so I should be able to put it all together now. Remember, it was an X major. So my X gets the major squared. My Y gets the minor, which is the square root of 15 over 4 squared. There you go. Cool. Did I skip one here? Okay. Hold on for a second. I don't know why, but apparently I went further on this problem. I don't know why. I always stop here. I really, that's always. I have a little extra. Apparently this will simplify down to a 4 there, of course. And then this square to square cancels, makes that 4 come to the top. 4y squared all over 15 equals 1. I don't know why I put that as something important, but, you know, just in case, there you go. You can always simplify it, but I am 99% sure WebAssign does not need simplified versions. I mean, I'd never do simplified versions. Okay. Last question of this section is an application kind of problem. So they have the sun at a focus, and then we have a planet. I don't know if it's the sun, if it's the Earth or something. I can't remember, but it's a planet going around the sun. But now nothing's in a perfect circle, and so there's a little bit of eccentricity there to make the ellipse. Blah 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 blah. Well, this distance here, the furthest distance you are from the sun, is called the Aphelion, while the closest distance you are is called the perihelion. Cool. Well, they give me what these actually are. The peri is 147,000,000, and my app is 153,000,000. And just remember that the sun, put a star there for the sun, I guess. The sun is at one of the foci, at one focus, singular focus. Okay. Like there's another focus over here, but there's nothing going on there. And there's your center. It's right there. Okay. Cool. How are we supposed to do this problem? Like, what are they wanting? They want the full equation of the planet going around the sun. Well, we're going to need majors and minors and all kind of stuff to be able to do this. I'm assuming it's that it's centered at 0, 0, because, well, that's what we're doing. And so they're saying that this distance here is the 153, and this distance here is the 147. Now, I've exaggerated it, and I've removed all those zeros because, well, everything's at 6 zeros, so I think we can do the math okay. What I want to do is I want to find this C distance right here, okay? And I also want to find this major distance right here. Major is always with a capital. It's not really, I just make it that way. I don't care about the minor. The minor is not important right now. If I can find C in major, I can find the minor myself. So I'm trying to think like geometrically, I guess you can say. How can I find these distances here and the distance there given what we have? Well, first off, I can say that this is also a major on this side, right? So I got two majors. Well, two majors should be the full distance, the 153, plus the 147. To solve for major, I divide by 2. And we get in a calculator. Yes, it's 150. Of course, it's 0, 0, 0, 0, 0, 0 kind of stuff. Lots of zeros. Okay, so that's my major. There you go, capital M. Major. Cool. How do I find my C? Well, if I take my major distance here and I subtract the 147 from it, it should work out. So C is going to be that major distance minus the 147. So I had 150 minus the 147. Makes a 3. 0, 0, 0, 0, 0, 0. So there's my C. And then I can find my minor. Let me just do the formula properly. C squared is equal to major squared minus the minor squared. So I've got, well, I guess 3 squared. You know what I'm going to do? I'm not going to assume that just 3s and whatever will work. 3 million squared, major of 150,000,000 squared, and then minus the minor squared. I'm going to just do little m squared. I'm going to solve for little m. We've done this a lot of times. I'm going to move these two guys. So little m is equal to the 150,000,000 squared minus 3,000,000 all squared, and then you're going to square root both of them. What you actually end up with, crazy stuff here, scientific notation. In fact, I'm not going to square root them. Let's back up a little bit. I'm not going to square root them because it doesn't really matter. So m squared, my minor squared, because I'm going to just plug it straight into the formula here in a second, is 2.2491e to the 16. So there's one of your answers. My major, if I want scientific notation, is, hold on. Actually, I need major squared. Major squared is the 150,000,000 all squared, which ends up being a 2.25e to the 16. Whew. And so total, put together, we got x squared over my major squared, because it was an x major if you go back. Y squared over the minor squared, y minor. And so I'm just going to plug them directly in. So this is my major squared, 2.25 times 10 to the 16. Notice e to the 16, 10 to the 16, the same thing. And the y, similar thing, 2.2491 times 10 to the 16. And then it equals 1. And yes, I typed all of this into the answer in WebAssign. That is how you do it. So, whew, that was a big problem. Thank you very much. Have a great day.